All right, we're going to take this example from checkpoint number 1. And I'll have you just read that by yourself. You can read that through. And what I did for this example is I took out the triangle DEG. Okay, and I took that out and just put that on my paper so that you guys can see that. So remember, it's looking for the angle EDG is 38, and then the angle DEG is 38 degrees more than our last angle. So how do we solve for what those two angles are? What we're going to be doing, what we know, is that we have 38 degrees plus our two other angles is equal to 180. So as we do that, we know that our last side is just plain x because we have not been given that. Now we're going to look at this last side, and we're looking at that. This is x plus 38. So we can write it as x plus 38. So you'll notice we have a pattern here. But what we're going to do now is I'm going to subtract 38 from both sides. Okay, and we get 180 minus 38 is going to be 142. And we still have, now we can combine our x's, so we have 2x plus 38 still. So we're going to subtract another 38. You may have done this all in one step right there. And that is going to be 104. So we have 2x equals 104. Now what we're going to do, remember we're going to divide here, and we have x equals 52. All right, so we have x equals 52. Now we're not done here because we have to find out what the measure of both angles are. So we know that angle DGE is equal to 52 degrees. And our last angle, which is 38 more, is 52 plus 38. So that's going to be 90 degrees. So our last angle, DEG, oh, I marked that wrong. So DEG is 90, and DGE is going to be 52 degrees. And there's checkpoint number 1. All right, example number 2, finding an unknown side lengths. The perimeter of a scalene triangle is 65 centimeters. The length of the first side is twice the length of the second side. The length of the third side is 20 centimeters. Find the lengths of the other two sides. So in this problem, we are given the 3 different sides, but we're told to find the variable so that we can find the complete side. All right. You'll notice that it says the length of the first side is 2 times, right? 2 times the length of the second side. So we have put a variable in for the side length. 2 times the 1, right? And then we have 20 centimeters. So the way that we're going to solve this is we're going to set it up in an equation. We have the perimeter is equal to 2 times plus the length of our other side plus 20. All right. We know the perimeter is 65, so we're going to plug that in. The perimeter is 65, and then we have 2x plus x plus 20. Next, we're going to just subtract. We're going to combine our like terms. 3x. Let me just back up there. Okay, I'm going to combine our like terms, and then what I want to do is I want to subtract. Okay, because we are combining our like terms on other opposite sides of the equation. Right. So we have 45 now is equal to 3x. I'm going to divide by 3, and we get x equals 15. So what this means is the length of this side is going to be 15. The length of this side is going to be 30 centimeters. And then we have our last side already, which is 20 centimeters. So we can go ahead, I'll just label that. So this is 15 centimeters. This is 2 times 15, which is 30 centimeters. Okay, so that is example number 2. All right, we're gonna go over checkpoint number 2. Right, it says the perimeter of an equilateral triangle is 42 meters. Find the length of each side. So that was our problem from before, so we'll section that off. So we need to remember, what is an equilateral triangle? That is when all 3 sides are the same. Right? So all 3 sides are going to be the same. That's all we know, except that the perimeter is going to be 42. So 42 equals 3x, because we combined all 3 sides to get 3x. And now we're going to divide 42 by 3, because we want x by itself. X equals 14. Now each side of this triangle is 14 meters. And that is checkpoint number 2. All right, we're going to look at example number 3, finding angle measures using ratio. The ratio of the angle measures of a triangle is 1 to 3 to 5. I'm just going to draw just a triangle so I can kind of imagine this. 1 to 3 to 5, okay? So that's just our triangle. It says, then classify the triangle by its angle measures. So the ratio, 1, 3, 5, I'm going to use that ratio to find out what each angle is. All right, I know that in a triangle, again, all 3 angles equals 180 degrees. We have 1x plus 3x plus 5x. Remember, we said this angle, this triangle, the ratio is 1, 3, 5. 1 to 3 to 5. Okay, so that's how I found this equation. Now, we're going to go ahead and combine our x's, or combine our like terms, and we have 9x equals 180. All right, we can divide and get x by itself, and we have x equals 20. Now, we're not quite done yet. We've done most of the work, but we need to still classify the triangle by its angle measures. So, our second step, okay, is going to be to plug back in and find the exact angles. So, we can do that by substituting 20 for x in the expression for each angle measure. So let's look. If we just have 1x times x, we're going to do 1 times 20. And our first angle is 20 degrees. Our second one is 3x. And we're going to do 3 times 20, which is 60 degrees. And then we have our last one, which is 5x, and that's 5 times 20, so we have 100. And because our largest angle is 100 degrees, we have an obtuse triangle. So it's an obtuse triangle. Okay, and that is example number 3. All right, this is checkpoint number 1, and it says the ratio of the angle measures of a triangle is 3 to 5 to 12. Find the angle measures, then classify the triangle by its angle measures. So again, we've got 2 steps here. What I did here was I drew out the 3, 5, 12 triangle. We've got 3x, 5x, 12x. Remember, this is the angle measure, so we're looking inside to the angle measures. We know that 3x plus 5x plus 12x we just put in a variable for our angle, is equal to 180. Using that, we can now combine our x's, our like terms. So we have 20x. So if we combine 3 and 5, we get 8, and then plus 12 is 20x equals 180. You can divide and get x by itself, and you get x equals 90. X equals 90. Just kidding. X equals 9. All right. So now that we have x equals 9, what we're going to do is we're going to plug that back in to our original equation. So 3 times x, or 9, is equal to 27 degrees. Now our second angle measure, 5 times 9 equals 45 degrees. And now we're going to look at our last one, which is 12 times 9, and that equals 108 degrees. Now that we have all three of these, we can find that it is an obtuse triangle. And there we are.